A solid sphere of mass m and radius r is placed inside a hollow thin spherical shell of mass M and radius R as shown in figure. A particle of mass m is placed on the line joining the two center at the distance x from the point of contact of the sphere from the shell, that is, the point of contact is this one. Okay. Find the magnitude of the resultant gravitational force on this particle due to the sphere and the shell. Alright, now first thing is first, we know the concept point is if a particle is placed inside an hollow shell, then the gravitational force between both of them will be 0. Now, in first case, r, x and 2r, that is, the particle is lying somewhere on this line, right? We must put a magnifying glass over here so then we can look what is happening inside. So I put a magnifying glass. The magnified part is like this, okay, and this is my outer sphere, something like this. Fine, and this is the center line, and the value of x, that is the distance from the point of contact, is given as it lies somewhere between r and 2r, so it lies somewhere over here. Alright, now one thing is clear, that if a particle is lying over here, let's say at a distance x, fine, this is my mass m dash, then the force acting on it, the force acting on m dash due to the capital M, that is the outer shell, will be 0, because of course the m dash is lying totally inside a hollow shell, so the force due to it will be 0. But there will be a force acting on m dash due to small m, and that will be given by g into m, that is small m. Okay, this small m is the mass of the sphere whose radius is x. Alright, again the same concept, the part lying outside to the particle position will not exert any force on it, so I'll say that this is my mass, let's say m dash. M dash is the mass of the particle, and let's say m1, that is the mass of this much part, divided by the distance between both of them, and that is given by r minus x, or x minus r, whatever, whole square. So the value of m dash, as we calculated in previous problems, is given by total mass of this sphere, that is small m, into this distance. This distance is my r minus x, or x minus r, right? X minus r whole cube divided by small r cube. So just substitute this value over here, so I get f m dash m given by g m dash into m into x minus r whole cube by r cube into x minus r whole square. So the force between m dash and m is given by g m dash m x minus r by r cube. That is the answer. In second part, if the value of x lies between 2r and capital 2R, fine, it means it is lying somewhere over here. Now again, when the particle is lying in this region, then again the force on the particle due to the outer sphere will be 0, because since again it is lying inside the hollow sphere, and the force on m dash due to small m can be easily calculated by g small m into small m, this is m dash, divided by r square. R square is the distance between the center and the particle, so the total distance is x, and this is the small radius small r, so it will be x minus r whole square. That is the answer. And in C part, it is lying outside the 2r, so clearly the force will now act due to the outer shell also, that will be given by g into m small m divided by distance between both of them. So let's say if particle is lying somewhere at this point, and this complete distance is x now, and this distance is capital R, so it will be x minus capital R whole square, and the direction of force is along the center line, that is downward. and the force that is acting on m dash due to small m can be calculated by again the same formula, and distance between them will be x minus small r whole square. Now since both the forces are acting in the same direction, that is along the central line downward direction, so the F net in this case is given by gm into small m by x minus r whole square plus gm into m dash by x minus r whole square. This is the capital R. That is the answer.